How do you test a FastMCP server without manually checking every tool response? We'll set up a Pytest fixture that automatically wraps your server in a client, then run assertions against the tools list. You'll see how to verify tool counts and structure, with the client handling connection cleanup for you. Import Pytest. From FastMCP client, import client. From FastMCP client transports, import FastMCP transport. From my project main, import MCP. At Pytest Fixture. Async def main MCP client. Async with client. Transport equals MCP as MCP client. Yield MCP client. Async def test list tools. Main MCP client. Client fast MCP transport. List tools equals await main MCP client. List tools. Assert len. List tools equals 5. This demonstrates the Pytest fixture pattern combined with dependency injection for testing FastMCP servers. The approach creates a reusable client instance that encapsulates server connectivity, allowing tests to focus on behavior rather than setup. What makes this distinctive is how it transforms server testing from a manual, error-prone process into a declarative, repeatable workflow. The pattern works by centralizing server initialization in a fixture, then injecting that fixture into test functions. This separation of concerns means connection logic lives in one place, while test cases remain clean and focused on assertions. The Async context manager ensures proper resource cleanup between tests, preventing state leakage that could corrupt results. This approach matters because it eliminates the testing friction common in RPC systems. Without it, you'd need manual client setup in every test, risking inconsistencies and maintenance headaches. The fixture pattern is particularly valuable for FastMCP servers, where you need to test tool registration, argument handling, and response formats across multiple scenarios. It enables rapid iteration during development while maintaining reliability in production. Let's break it down. Import Pytest. From FastMCP client, import client. From FastMCP client transports, import FastMCP transport. These imports establish the testing foundation. Pytest provides the testing framework, while client and FastMCP transport enable async communication with the MCP server. The transport class defines the protocol for message serialization and connection handling. From my project main, import MCP. This imports the pre-configured FastMCP transport instance from your project's main module. It serves as the communication bridge between your test client and the MCP server, handling all protocol serialization and connection management. At Pytest Fixture. Async def main MCP client. Async with client. Transport equals MCP as MCP client. Yield MCP client. This is Pytest's fixture pattern for reusable test setup. It creates a shared FastMCP client instance with automatic connection cleanup after each test, ensuring no resource leaks between test cases. The Async context manager handles proper connection lifecycle management. Async def test list tools. Main MCP client. Client fast MCP transport. List tools equals await main MCP client. List tools. This test verifies the list tools endpoint returns exactly 5 tools. It uses the main MCP client fixture to get a pre-configured client, ensuring consistent test conditions by reusing the same connection setup. The await handles the async call, matching FastMCP's async-first design. Assert len. List tools equals 5. This assertion verifies the test expectation. Exactly 5 tools should be registered. It fails immediately if the MCP server returns an unexpected number of tools, exposing configuration or registration issues early. FastMCP Async testing pattern. The Pytest fixture pattern with Async context managers creates a clean testing environment for FastMCP clients, mirroring production usage while maintaining isolation. A missing Async keyword on your fixture silently breaks the event loop, causing tests to hang without clear errors. This approach lets you test both simple tool counts and complex parameterized scenarios with identical setup.
The test that never runs still passes until the moment it doesn't.